This is Unit 6, Quads and Polygons, Lesson 6.1, Polygons and Angles. You should have your preview, Unit 6 preview notes available. There's our calendar for the next month. How to use this packet, follow the instructions given in the video. When you're told to pause, work on your own. Pause and work, then check your work. Always both watch and listen and follow. Don't just copy. When you're done, take 2 minutes and verbally review the content of the lesson. Get your notes signed by a parent or guardian affirming your efforts. You should be watching this right now, Lesson 6.1, Polygons and Angles. Don't forget to get a parent signature or guardian sign off. Let's do a review here. We're going to solve for all sides. And it says right there that you are not going to use a calculator. So you can see here that this is a 30, 60, 90 triangle on this side. So we're going to write our table out. Short leg, long leg, hypo. And over here is a 45, 45, 90. Leg, leg, hypo. And 30, 60, 90, the table is, 45, 45, 90 is leg, leg, leg root 2. 30, 60, 90 is short leg root 3, short leg times 2. Make sure you copy those down. I'd like you to pause and attempt to find these side lengths on your own, then restart the video and check. Okay, welcome back. Did you actually pause the video or are you just waiting to copy this down? If you're just waiting to copy, you're not learning. Pause the video, try this on your own, then restart. All righty, welcome back. So here we have our legs, and our legs are equal. So this is obviously 12 root 2 because the legs are equal. To go from here to here, we times by root 2. And 12 root 2 times root 2 is basically 12 times 2, which makes this 24. Now we come over here and we identify our short leg, which is right here. And to go short leg to hypo, we times by 2. And to go from short leg to long leg, we times by root 3. So we don't actually have the short leg, so it reads like this. The short leg times root 3 is 24. You have to work backwards. And you realize that you need a root 3 there, and what time, that'll make it 3, and it's going to be 8. And then 8 root 3 times 2 is 16 root 3. Check your work, modify the ones you got wrong. Now today we're going to start learning about polygons. Now poly is just generic for many. So a polygon is simply a many-sided shape. And you're going to know these terms: polygon, convex, interior, exterior, the term regular, and an n-gon. N is just the variable we use for sides. Ready? Go down this list and see how many of these you can fill out. For example, the prefix tri means 3, and the polygon with 3 sides we call a triangle. Quadri is the prefix for 4, and that's where we get the quadrilateral. See if you can't fill out the rest of those. I'll pause about 30 seconds. You should have hit the pause button to fill these out. Let's recap. Penta means 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. And a 5-sided shape is a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is nonagon. And 10 is a decagon. So a polygon is if you have a many-sided shape, then it is a polygon. Poly, just generic, means many. You don't know the number of sides. You have to be specific with your prefixes to know your number of sides, like hepta, hexa, octa, etc. So poly is the generic for all of those. Now the term regular means this. If you have a regular polygon, then all sides and angles are congruent. So the term regular means all sides and angles are congruent. Draw these two shapes. Now let's count the sides here. We have 1, 2, 3, 4, 5. So this is called a pentagon. Let's count the sides here. 1, 2, 3, 4, 5. Guess what? This is also a pentagon. Wait, that doesn't look like a pentagon. These are two different types of pentagons. A pentagon where all the sides bulge outward, that's called a convex. A pentagon where a pair of sides turn inward, that's called concave. What we're going to be studying today is specifically and only convex polygons, polygons that bulge outward. Concave polygons, all the rules I teach you in the next 20 minutes do not work. So examples of polygons, see if you can't name these. This one, 1, 2, 3, 4, 5, 6, 7. That's a heptagon. 1, 2, 3, 4. That would make that a quadrilateral. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a decagon. And of course the last one, 1, 2, 3, 4, 5, that's a pentagon. You need to have those prefixes memorized. Now we're going to do a little examination of properties about polygons. Here we have a quadrilateral. And it has 4 sides. 1, 2, 3, 4. 4 sides. And if we connect from one vertex, we see that the number of triangles created from a single vertex is 2 triangles. Each triangle is 180. So for a quadrilateral, the sum of the interior angles is 2 times 180, which is 360, or 2 triangles. Let's try the next one. The next one, 1, 2, 3, 4, 5. That's a pentagon. It has 5 sides. From a single vertice, we can draw 3 triangles. Therefore, the sum of the interior angles is going to be 3 times 180, which is 540. Let's try another one. This is a 1, 2, 3, 4, 5, 6. So this is a hexagon. It has 6 sides. From a single corner, you can draw 1, 2, 3, 4 triangles. So to find the sum of the interior angles, that's 4 times 180. And that is 720. Now, take a note here. There's a pattern between the number of sides and the number of triangles. When we have 4 sides, we have 2 triangles created. 5 sides, 3 triangles created. 6 sides, 4 triangles created. Each triangle adds up to 180. There's a pattern here. Let me say it again. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. There is a pattern between the number of sides to the number of triangles created. See if you can't write that out. The number of sides to the number of triangles created. Write that in your own words. I'm not going to fill that blank in for you. What you should have noticed is that the number of sides to get triangles is simply minus 2. So the sum of any interior angle, write the word sum, interior angles of any polygon is going to be the number of sides. We use n for number of sides minus 2. That gets us the number of triangles times 180. That's for the sum of the interior angles. Now, if all of them are equal, to get a single angle, this only works if it's regular, so I'm going to write for one interior angle, it's going to be whatever that sum is over the number of sides, which in this case, the sum is n minus 2 times 180 over the number of sides. We use n for number of sides. Now let's take a look at exterior angles. Exterior angles. What I want you to do is take this shape and you're going to extend all the sides and we're going to go counterclockwise. Ready? Extend the side. Now sweep that angle. Extend this side and sweep this angle. Extend, sweep, keep extending, and sweep. All of these angles that you swept are called exterior angles. They're the angles created when you extend the sides. Exterior angles. Those are all called exterior angles. We have an illustration of the exterior angles right here. Now, if you look really carefully, if you took all the exterior angles, go ahead and sweep them here. It's a little bit easier to see it. Keep sweeping. You're going to notice if you put all of these together, you're going to end up with a circle. If you took all those wedges and you put them together, you're going to end up with a circle. So this is a real simple truth here. The sum of exterior angles always add up to 360, regardless of the shape. The sum of the exterior angles always add up to 360. And if it's regular for one exterior angle, that's sum over sides. That's going to be 360 divided by n. That's for a single exterior angle. Now, this seems like a lot of equations, but let's recap what we have. The sum of the interior angles is sides minus 2 times 180. To get a single one, it's sum over sides. And your sum is n minus 2 times 180 over the sides, which is n. For exterior, the sum is always add up to 360. For a single one, it's also sum over sides, but your sum this time is 360 over n. Really important you get this memorized, so important that we have a jingle for it. Goes to the tune of Three Blind Mice. I'm going to sing it and underline keywords. If you're really on top of it, you're going to sing this too. Okay, so just to refresh your memory, Three Blind Mice goes like this. Three blind mice, see how they run, right? That's the tune. You got that in your head? And then it talks about a butcher cutting off their tails and all that lovely stuff. We'll play this again in class. So again, three blind mice, see how they run, You got the tune? Okay, I'm going to sing this here, and you are going to sing afterwards. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2 times 180. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2 times 180. Let's get this down. The sum of interior angles is sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon. So there's two versions. There's interior and exterior. Is sum over sides. Ain't this fun? So for the interior, n minus 2 times 180 over n. Exterior, sum over sides, except the sum here is 360 over n. We're going to go over this again in class. I'm going to do a couple problems with you here. Now, as you read through the next problems, keep in mind these 7 key words, and you should always, always, always highlight or underline these keywords as you see them. The first keyword is find the keyword interior. Should also watch out for exterior. Again, when you see these keywords, you should highlight or underline them always. regular. The word sum. Watch out for the words one or each. Watch out for the simple word is, are, was, and were, which all of these are versions of equal signs. Keep track of your prefixes. What number gon is it? Is it a hexagon, a pentagon, a heptagon, an octagon? So keep track of your prefixes. Ready? I'm going to do 3 problems here. It says, the sum of the interior angles of a convex polygon is a 1080. What is the polygon called? Keywords: sum, interior, is, which is an equal sign. Always spot your equal signs. 1080. What is the polygon called? That means what is its prefix or what is its number of size. Ready? Always start by writing your equation out. This is sum interior, sum interior. So you write the sum of interior angles, sides minus 2 times 180. Okay, so the sum of interior angles equals sides minus 2 times 180. Now, we plug in what we have. The sum of the interior angles is 1080. So the sum of interior angles is actually 1080. We're being asked to find out what it's called. Technically, what that means is we're solving for n, or the number of sides. So n minus 2 times 180. So our goal here is to solve for the number of sides and figure out what this polygon is called. So rather than distribute that 180, we're just going to divide it out. And 1080 divided by 180 is 6. How do I know? Because you can do the math backwards. So far, if I divide this out, I'm going to get 6 equals n minus 2. If I add 2 both sides, I solve for my n, which is number of sides. It's at 8. And what is that called? That's called an octagon. Let's try another one. Again, watch your key words. It says a single interior angle of a regular polygon is 36 degrees. There's an equal sign. How many sides does this regular polygon have? Okay, now we have a single interior angle. And it's regular, which means we are working here with each angle of a regular polygon. We're using this one right there. It's interior because it says it's interior. So we write down 1 interior angle equals n minus 2 times 180 over n. That's how we know the equation, by looking at our given information. Now our 1 interior angle is 36 degrees. So that's going to go on this side. 36 degrees equals n minus 2 times 180 over n. Our goal is to figure out how many sides it has, and that means code for solving for that n there. Now we have a fraction on the right, which means we have to create a fraction on the left, and we're going to cross multiply. Next line reads 36n equals n minus 2 times 180. Okay, so from here, we are going to add 360 to both sides. And we're going to minus that 36n to get it over to the other side. So I end up on the left, 360 equals 144n Okay, if you divide here, you end up with n equals 2.5, and that's incorrect because if we're dealing with number of sides, you have to have a whole number. So there's a typo in that one. We're going to skip that one. Let's do another example. It says the measure of a single exterior angle of a regular polygon is 60. What is that polygon called? Single exterior angle. That is, right, one exterior angle. That's going to be 360 divided by n. So right here, our one exterior angle equals 60. So you do 60 equals 360 divided by n. We're going to put this over 1. Cross multiply, we end up with 60n equals 360. And we divide. And our number of sides here is going to be 6. So it's called a hexagon. Let's do these ones together. I think you need more practice. It says the sum of the interior angles of a polygon is 1440. What is the polygon called? So we write the sum of interior angles, sides minus 2 times 180. And in this case, the is, we're going to do 1440. Sides minus 2 times 180. What is the polygon called? That means we're solving for n this time. So we divide by 180. I'm going to try 180 times 8. And so I know that's 8 right there. So I have 8 equals n minus 2. So I add 2 to both sides. So our n is 10, which means it's a decagon. It says find the measure of a single interior and a single exterior angle of a regular heptagon. And hep means 7 sides, so 7 is our n. So now we want one interior and one exterior. So it goes, each angle of a regular polygon, sum over sides, ain't this fun? Sum over sides. So for one interior, it's n minus 2 times 180 over n. For one exterior, that's 360 over n. So in this case, our 7 and in this case, it's 360. At this point, once you do your plugins, you're welcome to get your calculators out. 7 minus 2 is 5, so I'm going to go 5 times 180. And I'm going to divide by 7. I'm going to round to the first decimal place, 128.6 is a single interior angle. An exterior angle is simply 360 divided by 7, and that's 51.4 degrees. Let's do one more. It says 4 of 5 interior angles of a pentagon. A pentagon means our sides is 5. We want to find the measure of the fifth angle. So let's start by drawing a pentagon. 1, 2, 3, 4, 5. And for the angles, I have 100, and I have 80, I have 140, and then I have 150, and then I have a last angle that I don't know. I'm asking for the measure of that fifth angle. Now, if this was a triangle, it'd be really easy. You just take it away from 180. Why? Because all triangles add up to 180. Well, you know the same thing for pentagons, because all pentagons, you can do the sum of interior angles sides minus 2 times 180. So in this case, the sum of the interior angles of a pentagon, that's 3 times 180. That's 540. So all convex pentagons add up to 540. And I have 4 angles here. So I'm going to add those up. 100 plus 80 plus 140 plus 150. And I get that those 4 add up to 470. So now I simply subtract. And I get the measure of my last angle is 70 degrees.